All right, here are solutions for quiz 8, Math 112. You're told to pick 3 of the following 4 to solve. I'll go ahead and solve them all because I don't know which 3 you will pick. The first one, you're given this mess and asked to simplify it. Okay. Where to begin? I don't know. I guess down in the denominator, you might notice sine of x plus sine of x. Isn't that just 2 sine of x? Yup, sure is. So we can rewrite the denominator as just 2 times sine of x. The numerator, not quite as nice. You got 1 minus and then all this stuff. Sine of x plus cosine of x squared. You might think, oh, sine squared plus cosine squared. Yeah, that's great. That's just 1. No, I mean, that is just 1. But sine of x plus cosine of x squared is not the same as sine of x squared plus cosine of x squared. We'd have to FOIL this thing out. So let's do that. So we got 1 minus, and then inside the parentheses, if I FOIL this out, sine of x times sine of x gives me sine squared x. Sine of x times cosine of x gives me sine of x times cosine of x. But I'll end up with 2 of those because I'll have a cosine of x times a sine of x when I go through all my FOILs. So I got something like this, and then the last term, cosine of x times cosine of x, is just cosine squared x. Something like this. However, inside these parentheses here, I got a sine squared plus cosine squared, if you reorder these terms. And those are things you're always kind of searching for because you want to apply your Pythagorean's identity. Sine squared plus cosine squared is just 1. So I have 1 minus all this stuff. I got 1 minus 1 minus 2 sine of x cosine of x. This turns into 1, and then I subtract all this stuff, so I have to change the sign on both of these terms. So we'll take that and divide it by 2 sine of x. But 1 minus 1 is just 0. So from here, I get negative 2 sine of x cosine of x divided by 2 sine of x. And I can cancel out this 2 and this 2 and this sine of x and this sine of x and get negative cosine of x as my answer. All right, moving on. This mess apparently can be written in this form. So figure out what A and B are to have it in this form. All right. Well, the hint I gave you is to break it up into chunks. So I'm going to do that. This first chunk, I'm going to kind of just leave alone for now. I got 4 divided by 2 plus cosine of x. But this next chunk, I'm going to do a lot of simplification to, where I got cosine of x divided by 2. Note that you have a secant of x in both of these terms. So maybe I'll factor out a secant of x. And then what I'd have left behind would be 2 plus cosine of x. How convenient. The same denominator I got here. You could leave it here, but I've kind of trained you not to leave things in terms of secants. I've changed everything into sine and cosine. So I think what I'd do at this step is say, well, this is secant is 1 over cosine. So this is cosine of x divided by 1 divided by secant of x is 1 over cosine of x times 2 plus cosine of x. So what I have, I'm making this way harder than I need to, cosine of x over 1 divided by 2 plus cosine of x divided by cosine of x, which now that you have a fraction inside of a fraction, you can multiply by the reciprocal of the denominator, flip this up top, and you'll get cosine squared x divided by 2 plus cosine x. You might have been able to get there straight from here. Right? Secant is 1 over cosine, so you can move it up to the top if you change it to just cosine. Cosine squared over 2 plus cosine x, which is what I got way down here. Okay, stuff on the bottom. I got 1 plus cosine of x plus tangent of x times cotangent of x. Wait, isn't tangent just times cotangent just 1? Yes, in fact it is. If you can just see that, that's great. If not, you could change tangent into sine over cosine. And you could change cotangent into cosine over sine. And then you can either cancel these signs and cancel these cosines and call it 1, or multiply straight across and say sine times cosine divided by cosine times sine is just 1. Either way, you should get 1 plus cosine of x plus 1, aka 2 plus cosine of x. What I'm now going to do is take all the pieces and put them together. So I got this 4 divided by 2 plus cosine of x. Right, that was my stuff in red here. And then from that I want to subtract my stuff in green, which was cosine squared x divided by 2 plus cosine of x. And then I want to divide that whole thing by 2 plus cosine of x. Okay. In the numerator, I have a common denominator. It sounds kind of weird. So I can subtract these two things and call it 4 minus cosine squared x divided by 2 plus cosine of x. And then down in the denominator here, I'm dividing by 2 plus cosine of x divided by 1. So I can change this from a division problem to a multiplication problem if I multiply by the reciprocal of this. In other words, I make it 1 over 2 plus cosine of x. From here, we're almost done. I got 4, I guess I'm jumping up here, minus cosine squared x divided by 2 plus cosine of x squared. I want it to be this form. These squares are annoying. I don't quite have the squares, but if you factor the numerator, it's a difference of squares. You can make it 2 minus cosine of x times 2 plus cosine of x divided by 2 plus cosine of x squared. This 2 plus cosine of x and one of these 2 plus cosine of x's cancel, and you're left with 2 minus cosine of x divided by 2 plus cosine of x. So it says determine a and b. So a is the same as b, which is equal to 2. All right, moving on. That was a hard one. Okay, I've changed this problem a little bit. I think I want you to find the cosine of 108 degrees. I think that'll be, I don't want to say easier, less hard maybe. Still challenging, but not as bad as the original problem was. So given the sine of 54 degrees, find the cosine of 108 degrees. Here's your cosine angle addition formula. First thing is to note that 108 is just 54 plus 54. So the cosine of 108 degrees is the cosine of 54 plus 54, which is the cosine of 54 times the cosine of 54 minus the sine of 54 minus times the sine of 54. I'm given the sine of 54, so let's first we'll find the cosine of 54. And we can do that using the fact that the cosine of 54 degrees, cosine squared of 54 degrees plus the sine squared of 54 degrees is equal to 1. This is the Pythagorean identity. Nothing special about 54 degrees. This works for all angles. So cosine squared of 54 is equal to 1 minus sine squared of 54, which is 1 plus root 5 divided by 4 squared. So cosine squared of 54 degrees is 1 minus, if you FOIL this mess out, you'll get 1 plus 2 root 5 plus 5 all over 4. No, not over 4, over 16. So let's see, this one you could think of as 16/16. And then in this fraction I got 6 plus 2 root 5 over 16. The 1 and the 5 give me 6. So cosine squared of 54 degrees is equal to 16 minus 6 is 10 minus 2 root 5 over 16. Minus because I want to subtract all this stuff, so the minus has to hit both terms in the numerator here. So therefore the cosine of 54 degrees is equal to the square root of this thing that I just found, 10 minus 2 root 5 over 16, which you could write is the square root of the numerator, 10 minus 2 root 5, divided by the square root of the denominator, square root of 16 is just 4. Cosine of 54 degrees is this. That's the hardest part of this problem, because if you have the cosine of 54, you can then plug that in to this formula up here and say, let's see, how should I write this? The cosine of 108 is equal to the cosine of 54 plus 54, which is equal to the cosine of 54 times the cosine of 54 minus the sine of 54 times the sine of 54. The cosine of 54 is, you can use either of these two forms. I'm actually going to pick on this first form here. I'm going to say it's the square root of 10 minus 2 root 5 over 16. And I picked that form because I'm just multiplying it by the cosine of 54, which is the exact same thing. Essentially, I'm squaring that guy. Those square roots are going to cancel out, and I'm just going to get 10 minus 2 root 5 over 16. Minus sine of 54, that was given to me in the problem as 1 plus root 5 divided by 4. And I want to multiply that by 1 plus root 5 divided by 4. Wait, I feel like I've done that before. Here we go. 1 plus root 5 over 4 squared. That's just equal to 6 plus 2 root 5 divided by 16. And so if I subtract these two guys, I got 10 minus 6 is 4. And then I got negative 2 root 5 minus 2 more root 5. I have minus 4 root 5. And that's all over 16, which if I factor out a 4 from the numerator, I get 1 minus root 5 divided by 4. Whoa, weird. Pretty similar to that. Coincidence? Nope. Although I'm not sure I could explain why. I'll call that good. So right here's your answer. I'll tell you this form. So I think your answer will end up being A equals 1, B equals 4, maybe something like that. If I say that the form is A minus the square root of 5 over B, maybe. Yeah, good enough. All right, last problem. Tangent of 5 pi over 12. Whew, in this form. Well, I don't know. You might like radians. I don't like radians. I'm going to first convert to degrees. I'm going to say 5 pi over 12 times 180 divided by pi is, let's see, the pi's would cancel out and I'd get 5 times 180 divided by 12. Well, let's see. I know that 6 goes into 180, so I could say this is 5 times 30 over 2. The pi's cancel, and 180 is 30 times 6. 12 is 2 times 6. So this is 5 times 15, which is just 75 degrees. You could have reduced this, well, whatever. One way or another, you figure out that what we're asked for is the tangent of 75 degrees. I could figure out the tangent of 75 degrees. One way to do it would be, well, that's just the tangent of 30 degrees plus 45 degrees. How well do you remember your unit circle? Because it will be very useful to know that the tangent of 30 degrees is 1 over root 3, and the tangent of 45, I'm going to show you how you can come up with those. Say you didn't know what the tangent of 30 degrees is. It's going to be useful for this problem. The tangent of 30 degrees, tangent is sine over cosine. So it's sine of 30 degrees over cosine of 30 degrees. Sine of 30 degrees is 1/2. Cosine of 30 degrees is root 3 over 2. If you multiply by the reciprocal, you get 1 over root 3, or root 3 over 3 if you feel like rationalizing the denominator. Tangent of 45 degrees is sine of 45 degrees over cosine of 45 degrees, which is root 2 over 2 divided by root 2 over 2, which is just 1. Knowing these two values will make this problem a lot easier, because the tangent of a plus b is just equal to, using this formula up here, the tangent of a plus the tangent of b divided by 1 minus the tangent of a, tangent of 30 times the tangent of 45. Plugging in the values, tangent of 30 is 1 over root 3. Tangent of 45 is 1. And then 1 minus tangent of 30 is 1 over root 3 times 1. So the way I have this written right now is it is close to this form, but not quite there yet. But I think I can get it into that form if I wrote it more as a fraction. So let's do that. Let's get a common denominator. I got 1 over root 3 plus root 3 over root 3 in the numerator. And in the denominator, I got root 3 over root 3 minus 1 over root 3. So what I have is 1 plus root 3 over root 3 divided by root 3 minus 1 divided by root 3. So I got 1 plus root 3 over root 3 times, because dividing fractions is like multiplying by the reciprocal, root 3 minus 1, cancel out those root 3's, then you get 1 plus root 3 divided by root 3 minus 1, which is equal to, let's write that one more step. Adding these two numbers together, addition's commutative, you can write it like this. So A equals 1 and B equals 1. Alright, that's finally the end of this video.